Okay, this one's a rational function, and the rational function, the domain of this thing is all real numbers. We're going to take its derivative. Before I do that, though, I want to write this as x squared plus 5 to the minus 1. So f prime is going to be minus 1 x squared plus 5 to the minus 2. The derivative of the inside is going to be 2x. All right? Do the second derivative now. And yes, we'll look at the k. If you want, you can rewrite this as minus 2x over x squared plus 5 squared. However, when I take the derivative, I actually take the derivative of this guy over here. All right, what do you get? Well, it's a product rule, so let's go through that. And I'm just going to write the first function down. I'm going to call this the first one. I'm going to call this the second one. So the first function, I'll write this over here. Times the derivative of the second function, which is 2, plus the second function, which is 2x, times the derivative of the first function. Again, this is the first function. What do you get there? Well, minus 2 times minus 1 is 2. Then you're going to get x squared plus 5 to the minus 2. I know this is more difficult, by the way. And then what do you get? The derivative of the inside. I'm sorry. I made a mistake there. I'm talking and not thinking. My pencil out. So, you know, I brought the minus 2 down, so it becomes minus 3. And the derivative of the inside is going to be 2x. You're going to know you're going to notice that you make mistakes on these things because they look kind of nasty looking. But I'm going to start to factor it. And one thing I noticed, a 2 definitely pulls out from both of those terms, by those two terms. What else pulls out? Well, I'm going to pull the worst thing possible out, which would be x squared plus 5 to the minus 3. All right, let's be careful about it. I'm seeing the first term, and I pulled some things out from that. Certainly pulled a 2 out, so I certainly have a minus 1 there. And then what do I need? I actually need an x squared plus 5 as a factor to get the minus 2. Let me go to the next term. What do we have over there? Well, again, I want to remind you, I pulled a 2 out. I pulled this out. And what am I left off with? 2x times 2x, which is 4x squared. All right? I'm going to keep rewriting this until I get something that looks somewhat neat to me. I don't like the negative exponent, so I'll write this as x squared plus 5 to the third power. I do see the 2, and I'm going to simplify what's in this grouping symbol here. You get 4x squared minus 3x squared, 4x squared minus 1x squared, which is 3x squared. Then you get minus 5. So the derivative probably here was probably the most difficult derivative I had to come up with, right? So let's just check it, see if we did okay. Did I get the first derivative? I did. Was I able to get the second derivative? I did. What am I doing now? Let's go back over it. Points of inflection. So what am I doing? I'm looking for critical numbers. And remember, the domain of this thing is all real numbers. Well, this guy is never 0, so I'm not worried about that. It's this guy I'm worried about. Is it ever equal to 0? Well, it's equal to 0 when 3x squared is equal to 5. And that means x squared is equal to 5/3, which means x is equal to plus or minus the square root of 5/3. Put my number line down, and this is going to be the second derivative we're analyzing. And what are we doing? We have two critical values. One is at minus the root of 5/3. The other one is at the root of 5/3. We take test points. I'm going to say this is probably the easiest place to go, just a 0. You're going to plug it in here. That's the second derivative, by the way. And it's pretty easy. The bottom's positive. It's always positive. The top would be negative there. So what do I know about this thing? It's concave down. All right, let's do the next one. After the root of 5/3, and someone says, what number are you going to pick over here? I'm going to play it safe. Say 100. Plug it in. What do you get? Positive everywhere. Concave up. Let's take a test value over here. I don't like minus 100. Again, playing it safe. What do you get? Everything is positive. What does that mean? When I say everything positive in the second derivative. So we got this over here. I got my points of inflection. Where do they occur? Write this down for you. They occur at, minus the root of 5/3, f of minus the root of 5/3. And the other point of inflection occurs at the root of 5/3, f of the root of 5/3. All right, let's take a look at the key. And we already checked the derivatives out. Points of inflection occurs plus or minus root 5/3. All right, let's just go over, concave up, concave down. And again, what I was looking at, the intervals, it's concave up here. So that's from minus infinity up to that negative minus root 5/3. I'm sorry, minus root 5/3. And it's concave up over there. So that looks reasonable. And it's concave down between those two numbers. And we're good to go. Thank you.